So, have you ever tried to manage a really chaotic audio setup?
Oh, yeah.
I'm thinking, you've got a synthesizer blasting a loud line level signal, then a super quiet sensitive mic over here.
Right.
How do you get them to play nice without, like, a mixing desk the size of a dining table?
It's a real recipe for disaster if you
Hmm.
aren't careful. I mean, if you just jammed them all into a standard splitter, you get distortion, signal clashes,
Yeah.
just a lot of noise.
Do you need a traffic
So
controller?
exactly. You need a traffic controller.
Yeah.
And that's basically what we're looking at today with the Kramer VA-14.
Kramer VA-14.
Uh,
Okay. It's billed as a 4-channel balanced audio mixer.
yep,
It's tiny. I mean, it's about the size of a paperback book, but the specs, they suggest it's doing some pretty heavy lifting.
they do.
Before we even get into the knobs and dials, I have to ask about that word in the title, balanced. We hear it all the time in pro audio.
Yeah.
What does it actually mean for the listener?
It's really the difference between a clean signal and a buzzy one.
Oh.
A balanced cable uses 3 wires to carry the audio. And it uses this clever little trick of physics to basically cancel out any electrical noise or interference it picks up along the way.
So when Kramer calls this a balanced mixer, they're promising that professional standard of silence.
That's it. It keeps the traffic on the road and gets rid of all that static and interference.
That definitely sets the stage. Now, looking at the back of this unit, I see 4 XLR inputs.
Hmm.
And usually when I see XLR, my brain just goes microphone only. Is that the case here?
And that's where this little box really surprises you. Those
Oh,
4 inputs are completely agnostic. You can plug in a microphone or a line level source like from a media player into any of them. You don't have to
fair.
worry about matching specific ports.
So I could have, what, 3 loud video feeds and 1 really quiet mic, and it'll just handle it.
It handles it beautifully. You've got individual gain controls for every single input.
Oh, for each one.
For each one. So you can balance that loud synth against that whisper quiet microphone. Plus you have separate master controls for the main output and for the headphones.
Speaking of microphones, there's a switch here for 48V DC, phantom power.
Yep.
I know some mics need that to work, but if I've got a mix of different devices, isn't sending voltage down the line kind of dangerous?
It can be catastrophic.
Hmm.
Seriously. If you send 48 volts into a laptop output or, say, a vintage ribbon mic, you could just fry the electronics.
Wow. Okay.
But the VA-14 solves this by making that power individually selectable. You can turn it on for channel 1's condenser mic and leave it totally off for channel 2's line input.
That seems like a pretty crucial safety feature.
It is.
Now let's talk about noise, the hiss in the background. You flagged some numbers on the signal-to-noise ratio that seemed, well, completely different depending on where the audio is going. What's going on there?
This is really about understanding what each port is for. Think of the audio signal like a car on a road. The main line out is like a freshly paved highway. It has a signal-to-noise ratio of 84.3 dB. That is incredibly clean. The road noise is almost non-existent.
But the headphone output was way lower, wasn't it? Something like 45 dB?
It is. But that's
Mhm.
because the headphone jack is just a surface road. It's just for monitoring, for checking. Is the signal there? It isn't meant for the final broadcast or recording.
I see.
Kramer put the engineering money where it really counts.
Yeah,
That line-out path that goes to your speakers or your recorder.
that makes a lot of sense. Don't judge the recording by the headphone jack.
Exactly.
Now, here's the stat that really stumped me. The bandwidth is listed as greater than 40 kilohertz. I thought human hearing just taps out at 20 kilohertz. Why are we paying for a frequency range we can't even hear?
It's all about headroom.
Headroom.
Yeah, imagine you're in a room with a ceiling that's exactly 6 feet high.
Yeah.
Even if you're shorter than that, you feel cramped, right?
Mhm.
And if you jump, you hit your head. In audio, if the electronics stop strictly at 20 kilohertz, you often get distortion or phase shifts that actually trickle down into the range you can hear.
So by pushing the ceiling up to 40 kilohertz.
You ensure the part you do hear, that 20 hertz to 20 kilohertz range, is completely linear and relaxed. It removes the strain from the system. It helps the audio feel more open, even if you're not consciously hearing those ultrasonic frequencies.
That's a fascinating way to think about it. It's almost over-engineered just to make sure the basics are perfect.
Mm-hmm.
Practically speaking, this thing is small, but it's not exactly cheap. We're seeing a price around $516. Who is this for?
It's for the broadcast truck, the small studio, a high-end presentation setup. You can actually rack mount two of them side by side. You're paying for that balanced silence and the ability to mix four complex sources with zero distortion.
And the distortion is low.
Vanishingly low. We're talking 0.007% in THD on the output.
So it's a lesson in specific utility. Take complex signals, mix them with high precision, and keep the footprint really small.
It solves a chaotic problem without introducing new ones. That's really the mark of good hardware.
It really makes you wonder about that invisible control. If this box is preserving audio frequencies up to 40 kilohertz that we can't physically hear, does that extra headroom actually change the feeling of the audio we do hear? Something to think about next time you press play. Thanks for listening.